Good morning. This is your stats sensei, Mr. Spensei, and this is an assignment on one sample proportions, and we're going to do a hypothesis test and confidence interval. So, except we're going to leave out the conditions on this. With the rise of online education, more and more students are opting to take courses remotely. However, one of the biggest challenges faced by online educators is keeping students engaged and ensuring they complete the course. Research suggests that 85% of students enrolled in an online course complete this course successfully. So we kind of have a claim. This sounds like this is our null hypothesis, HO, where the population proportion is 85% or 0.85. And we know it's a proportion because they gave it to us as a percent. However, the director of an online university, Dr. Martinez, is concerned that the completion rate at his university is lower. Ooh, that sounds like that's probably going to be our alternative. Sounds like our alternative is going to be a less than 85%. So less than that national average of 85%. Dr. Martinez knows that many students drop out or fail to finish their online courses for various reasons, including lack of motivation and the flexibility of self paced learning. To assess this situation, he took a random sample. Hey, that's good. That'll take care of our conditions when we get to those tomorrow of 120. So we have a sample size of 120. So that's going to be important. N is 120 out of a population. Oh, we have a population size of 1,500, which is nice to know that 10 times 120 is 1,200, and that'll be less than 1,500. There's our population who enrolled in an online course over the past semester. Out of those students, out of the 120, 100, so this looks like our X, and we'll need that in order to calculate our P hat because we don't want to forget that P hat equals the X over the N, the number of successes over the total population. Dr. Martinez wants to test if the completion rate is significantly lower. So, okay, that's confirming what we thought before that HA is going to be a less than. All right, so our first assignment at alpha equal 5%. So there's our alpha level, significance level. Does Dr. Martinez's university have a lower, once again, confirming the fact that our HA is going to be a less than online completion rate than the national average, which is 85%. Well, you can already see already that there's our formula, which is our sample proportion minus our population. Please don't forget, this is a sample and this is the population. Also, since we're running a test, when you run a hypothesis test, the standard deviation will be based on the population. All right, so this will always be based on the population, not on p hat. Okay, so when we went through the material, we identified that the number of people, students that he had passed was 100 passed out of, or 100 completed the course out of 120. And the claim was 85 or 85%. But what we didn't have is p hat. We'll simply put 100 divided by 120 is 833. And let's take a look at that and just prove it to ourselves. So 100 divided by 120 is 0.833. So that's our sample proportion. All right. What are we actually doing? We're going to run a one proportion z-test. Okay. So with that said, when we run a one proportion z-test and we go about drawing it, one proportion z-test will always have, we always will be centered on the population. So our drawing needs to be centered on the population. And we said that our population was 0.85. And we had a sample proportion of 0.833. And we also said lower, so this would be a less than. And you've noticed that we're also consistent there. We have a lower. So then we go ahead and plug in, which is no great surprise. There's our plugging in our p hat minus our population. And once again, please make sure that when you're running a test, you're using the population down here. All right, because it's going to be different for a confidence interval. So you use the population P for the standard deviation or standard error when you're running a test. All right, so our hypothesis P equals 85%, or you could have put 0.85. And we have P is less than 85%. And I want to point out to you, lower, lower, and lower. We're all consistent so far. All right, because we're just going, hey, this is what they're asking us to do. So we're going to need to go ahead and run this test. And we're skipping conditions. We'll do those in a warm-up tomorrow. So stat test, one proportion z-test. We have a claim of 85%, or if you preferred, 85 divided by 100. And we have an x of 100, number of successes of 100, or number of people who completed the course, out of 120. And we think it's going to be lower, and we calculate, and we get a p-value of negative 0.5113. All right. So once again, we're still consistent at this point. Lower, less than, less than, less than. Everything's the same. But then we get over here, and we notice that our p-value is greater than. Here's where I have to compare. So it's going to be, this inequality is based on our comparison. And 0.3045, which we calculated, is greater than 0.05. Make them the same length, but 3045 is definitely greater than 500. So our decision here is to fail to reject the null. All right, we're going to fail to reject the null. All right, so continuing on. The next thing, it says create a 95% confidence interval for the proportion of online courses students at Dr. Martinez's university complete. All right, so we're going to sit there and go, hey, how many do they complete? We're going to try to estimate it using a 95% confidence interval. Well, our formula is simply the sample proportion, and please notice we're working with the sample here, and we're also working with the sample here. We're working with p hat. Up above, we're working with the population. Don't make the mistake. Be careful. All right. So we need to calculate our z star because we already have p hat. P hat came from here. All right, so we already have that, but we need to calculate z star. And to do that, we're going to go second vars, inverse norm. Oops, don't know what I have in a calculator. Second vars, inverse norm. And we want a 95%. So parenthesis 1 minus 0.95, close parenthesis, divided by 2. All z-scores have a mean of 0, standard deviation of 1, and we always want it to the left. So please make sure you make that number positive, and here we go. There's the positive values. At this point, I can go ahead and start plugging in because we've already calculated p hat. We had that from above. All right, so we just plugged it in. So there's our p hat right here and p hat right here. Now, please remember we actually calculated that. And this is our sample size. And this value right here is incorrect. This should be 1.9599. Those two need to match. All right. And when we're running a one proportion z interval, that's not a surprise. But before we do that, we need to remember that whenever we're doing this, we need to be centered on p hat. Confidence interval, hypothesis test is centered on p. The confidence interval is centered on p hat. So we're centered on that 0.8333 that we calculated by going 100 over 120. That was our p hat. And we're going to get a lower bound and upper bound. So to do that, we're going to go stat test, one proportion z-test. And, oops, I'm making a lot of mistakes. Sorry about that, guys. Stat test, one proportion z intervals. We're going to have to scroll all the way down to letter A. and we have an X of 100, an N of 120. We want a 95% interval. And when we do that, we end up getting an interval of 0.7665, with this being our lower bound and this being our upper bound. All right. Sorry about the errors there, but I appreciate you watching and look forward to seeing you on the next one. Thank you.